Welcome back. Hello again. It's Miss Amanda welcoming you all back to another year of exciting science videos. Today's topic, we will be discussing something that every young kid loves, and that is volcanoes. So I'd like to start off with drawing a simple diagram just to point out a few of the major structures of a volcano via a simple diagram. So what we want to do is draw the magma chamber, which is underneath the surface of the earth. And so we have a lot of hot rock, or rock that's been melted by the high temperatures, and whenever we get hot rock melting, we call that magma. So I think you all know what magma is, but it's only underground, so you never get to see it unless you could actually design a vehicle where you could plummet yourself down into the earth's crust to see it, but then you'd probably melt. It's just so hot. So imagine putting chocolate into a saucepan and placing it over the heat, and you will see the chocolate melting. We call that molten chocolate or molten rock. We call that magma. Now we have a magma chamber here underneath the surface of the earth. So this is the earth here, in this line here, and we can actually draw a vent moving up, and all of a sudden it starts to bubble up under high pressure. And when you get that happening, the magma likes to erupt. All right, it likes to erupt out into the atmosphere, and when it does that, the magma reaches the air and it turns into lava. So it starts to cool. Before it starts to cool, the lava can ooze down and form sides of the volcano in layers. So the first layer would harden, and then if the volcano is still erupting, the magma turns into lava and it forms another fresh layer on top. So hence the volcano starts building and building and building till it can get quite large. So this is the magma chamber where all the rock is melted, and we call that molten rock or magma, and it forms under pressure. It finds a little break in the earth and it forms a vent, and it travels up a vent and it erupts and it forms that lava, and then the lava cools and you get the volcanic rock. So you get the size of the volcano. Over here is a crater where the lava erupts from the earth. Now what I'm going to do is show you two examples of some rocks. So here we have a rock, and here we have a rock. Now obviously if you look very carefully with your scientific eyes, they might look different in shape. One might be slightly lighter grey, and that might be more of a creamy colour, but they behave in different ways when you introduce water. Okay, so we've got a little glass of water. One of the rocks is going to do something very, very interesting when you put it into the water. This one here, let's put it in, and what happens to it? What do you think will happen? It's either going to do two things, sink or float. So right now I want you to say in your mind whether it's going to sink to the bottom or float. Okay, let's see what happens. What happens? It sunk to the bottom. So it must mean anything that's very heavy, or what we call dense. There's a lot of particles, a lot of sand and sediment crammed into that rock, and it's very tightly squished. It's going to be heavier, or we call that more dense. Now this rock here looks the same size, but if we put it into the water, two things: is it going to sink or float? I'll let you have a think. Okay, I know what I think it is going to happen. Let's test it out. And look what happens. It actually floats on top of the water. All right, even though I tried to push it. So what we're suggesting is that, why does one rock float and one sink? This is obviously less dense. So the particles that make up this particular rock, there aren't so many squished into the same size or shape. So therefore, it must be lighter, and it is less dense. It allows the rock to float. If you have a look very carefully, I've got another one of these rocks. If you look very carefully here, you might be able to see these dark spots, which I'm pointing out are a lot of holes in the rock. Okay, here. So this is what we call a volcanic rock, or an igneous rock, and it is formed when lava actually cools. And you may know it, or your parents may know it, as a pumice stone, and they use that to rub off rough parts of their skin, particularly on the foot. But this pumice stone or igneous rock or volcanic rock is very light because it has a lot of gaps inside when it's forming a lot of bubbles. And as the bubbles burst and the rock cools, you've got holes. So that makes it a lot lighter. So there is an example of a volcanic rock. This is an example of a rock that they got from a river. It's a sedimentary rock, and it's got a lot more particles inside. So that will sink and that will float on top of water. So there you have it. I will then now show you how to make lava with some simple ingredients from the kitchen. I will show you what happens when you put these ingredients together, and then we'll show you how to make a volcano on a plate out of newspaper. And it's going to look something like this, okay, with a little vent in the middle to put your lava flow through. So that's basically what we're going to end up today. You can make a small one out of newspaper, or if you get adventurous, you can make a larger one. Just keep building it up until you get a volcano as large as you want. All right, so I will show you how this is to be done. So in order to demonstrate a lava flow, I like to take the children through the chemical reaction of mixing bicarb with vinegar. So we have our bicarb here, and which I keep in a container. We will just put a teaspoon in the middle of the plate and put the lid back on for science safety, as always. And we have a little cup of white vinegar. Now, what I want you to do is listen very carefully for the bubbles, because bubbles will form as soon as vinegar mixes with the bicarb. There'll be an instant chemical reaction, and a chemical reaction means that you mix one thing with another and something happens. You'll be able to hear and see with your science goggles bubbles being created, bubbles of carbon dioxide. That my lungs are actually producing carbon dioxide as I talk, so you can imagine a lot of carbon dioxide gas bubbles coming out of my mouth as I talk to you. We're going to create that on a plate with vinegar, white vinegar, and bicarb of soda. So I want you to see the bubbles, and if you listen very carefully, you'll be able to hear them, and that is the chemical reaction and the basis for making our lava flow with our volcanoes. Let's go. Okay, let's do some more. So here we are, we have our list of ingredients for the lava flow, to create the lava flow, and it's basically a chemical reaction that we will be creating for the lava flow. So the main ingredients will be the white vinegar, and I'm sure you will have a bottle of white vinegar somewhere in the pantry that you could collect. We have some bicarb of soda, and we have some dishwashing liquid in liquid form. Doesn't matter what colour it is, this one so happens to be green. If you want to make your lava flow even more spectacular, every kid loves these food colours, and they come in a range of 4 different colours. You have the blue, the green, the red and the yellow, and the children can tell the colour inside the bottle from the colour of the lid. So I think what will happen is that we'll use red for the red lava, red hot lava. So what we will do is I poured a little bit of vinegar into my cup. If you have a pipette at home, you can encourage the children to use the pipette. Otherwise, we can just simply tip the vinegar into the vessel. So I'm going to show you the lava flow. I do have my bicarb in a container, and we just get a little mini spoon, and we might place 2, let's try do 2 heaped spoons of bicarb in there. And a good scientist always puts the lids back on. So let's just do that for everybody to show science safety is the first. So we don't need this anymore. We don't need this anymore because we've got bicarb of soda in here and vinegar. Now, if you want to make the lava flow even more thicker and ooze out the top of your volcano, I would suggest you put a few drops of liquid detergent in your vinegar and just give it a little stir. Don't stir it too hard. We do not want to create a lot of bubbles in the vinegar. So now that we have vinegar and the liquid detergent in there. At this stage, you can put some red into the bicarb of soda, 2 drops, or you can put it into the vinegar. And put the lids back on for science safety and just give it a little stir. And you'll find when you start to pour or pipette some of the vinegar in, you'll see something happening. Have a look. You'll see the lava oozing out as the vinegar mixes with the bicarb. And if you listen, you might be able to hear some bubbles popping, but you can actually see the foam. So what happens is the detergent actually makes the vinegar and the bicarb mix together and it gets soapy, so it starts getting thicker. So I think that would be something, an addition that you could add to your volcano to watch the lava flow. And if you really want to get adventurous, you can put some more drops on top and of food colour and watch it dribble down the side. Here we go. There you go. Alright, so that's a pretty simple way of creating lava flow with some basic ingredients of vinegar, white vinegar, bicarb of soda and some liquid soap. So here's how we make the volcano. It's very simple and it really does not cost a lot. This can happen, you can use newspaper, you can use a whole sheet or you can cut it in half. For the purposes of making a small volcano, I'm going to make it with just 1 page of newspaper and a plate from the kitchen. And all I'm going to do is add a little bit of water onto the plate. I'll tip some there. Lids on, again for science safety. I'm just going to scrunch my paper up like this, not too tight, and just roll it around in the liquid to wet the paper. And at this stage, the children will be noticing how the paper, when it soaks up the water, it gets sort of soft and it gets sort of wet, and also it starts going dark. So you'll notice when you wet paper, as it soaks up the water, the paper gets darker, and then you know your fingers are wet. Don't worry about the ink. So at this case, when I've made sure that the whole part of my paper is wet, I'll get my pointer finger and place it right in the center of the paper and use my fingers to kind of squish it around my hand or my finger, my index finger or my pointer finger, and you have yourself a little volcano with the vent here where my finger went, and we place it back on the plate. So that's all you have to do. That is it, the volcano with the vent. Next thing to do is to get the bicarb of soda and sprinkle it into the center of your volcano. Now I would use my pointer finger to get tap, tap, tap so it goes in, and it doesn't matter if you get a bit on the outside, it just adds to the spectacular movement of the lava. The next thing we will do is that we can add some food colouring because we love food colouring. We can put some in the middle, a little bit of red, and I introduce paint, which we're going to dribble down the side of the volcano to just make it a little bit more spectacular, and red represents the fire. We have some yellow. You can go berserk. This is where we start having fun with our little volcanoes. And let's try green, a little bit of green, and a bit of blue for effect. All right. Okay. Now, let's get our vinegar with our red food colour in with a little bit of, what was that? What's that magic ingredient that allows the lava to foam up? You have it right. It's the liquid soap. All right, so we use our pipette and we'll just place it in, and you can see it erupting. All right, erupting down the side. And you'll notice that with some volcanoes, if the side is gentler, the lava flows out one side. If it's a little bit steep on the other side, obviously the lava can't flow out, but there will be little holes where the lava can escape. So that's a very simple demonstration of how to make a newspaper volcano on a plate and colour it with your paints to make it a little bit more realistic. One clue, if you would like to make your volcanoes a little bit more sturdy, instead of using paint, you can actually put PVA glue on top of your newspaper and rub it in with your fingers and let it dry for a week or a couple of days. The volcano will be hardened. Then you put your paint on top of it the following week, and then you do your experiment. So there's another little clue or hint to make your volcano durable, so that if you're doing this in the centre, you can take it home, the kids can take it home, or the children can show their parents and you can sit down together and make it. So I hope you have a lot of fun with that. So I hope you had some fun learning about how to make your volcano on a plate and learning about the igneous rock or the volcanic rock floating in the water. Let's hope that you can get some examples of some volcanic rocks in your searches as a little scientist exploring for new things. So I hope to see you back for the second video of the year. It'll still be on volcanoes, and I hope you like making Play-Doh, because we're going to be making some Play-Doh and we're going to be doing some fantastic discoveries of the inside of a volcano. See you later.